Alright, so this is similarity and right triangles. Is this the last topic I gotta teach y'all for? No, we got one more after this. Second to last topic for this unit. Before we start though, we need to kind of refresh your memory by doing some simplifying of radicals. So let's see what you remember, because I don't want to do this. Juan, you gonna volunteer to do the first one, and then Lucille do the second one. You don't remember? And Jamal, I don't know if you do them how we do them, and we're gonna find out.
You gotta break the part one.
You gotta do it like how we did it last year?
Yeah.
And this year too? We did it in here too. You know?
Like how you break it apart. Just break it apart.
Yeah. Like what goes in like 45?
Yeah.
Oh,
We'll see one.
so we could do like 9 and 5.
There we go. Okay, Juan. It's a good start, son. 9 times 5. Okay.
So we cut 9 into 2 pieces.
There we go. 3 and 3 right here. Good. And like he said, that's a double. So Juan, I'm still gonna need your help. You gotta instruct me from here, sir. Okay. 5 times 3, because this 3 is coming out. What's gonna stay inside, Juan? What you didn't use? So outside you got 5 times 3. Most of the kids in the other class didn't see this, but Juan saw it. There was already a 5 outside. That's where this 5 outside comes from. And then we moved the 3 out. So we have double 3s. That means we can square root that. So we bring that out. 3. And then cleaning this up, Juan, what should it look like? Man, you doubted yourself and you didn't do that, but now we see what Nasir on. Sliding on over. Nasir. 90 and 2. Alright. Oh Lord, you about to do it. I'm about to see, about to keep doing this. Somebody tried to do this last period. I'm keep doing 2s. 9 and what now? Oh, my bad. It's 3 times 3, y'all. My bad. And then what? 2 and 5. I'm gonna put the 5 first to just make it easier. Okay. Let's talk about the doubles we got under right now. What you got? That's it. And then the 2 and the 2. So what's coming out and what's already out? Tell me what the right. Let's talk about that 2 that's already out there. So 2 times, then what else you pulling out? 3 times 2. What stays under? 5. Alright, so clean it up. Alright, just a little recap. Simplifying radicals. Recap. I'm probably going to do that in here. Just let me zoom out a little bit. Alright. So, with similarity today, we're going to look at geometric mean, the altitude theorem. Says, in any right triangle, the altitude from the right angle to the hypotenuse divides the hypotenuse into 2 segments. The length of the altitude is geometric mean of the lengths of the 2 segments. And then there's also the geometric mean leg theorem. The length of each leg of a right triangle is the geometric mean of the lengths of the hypotenuse and the segment of the hypotenuse that is adjacent to the leg. Jesus, it's a lot to say. Honestly, I just went on a read through them because honestly, it's not gonna mean a lot to you. Visuals might help though. I mean, that's just the written theorems. Let me just explain something to you. So if you got a triangle, similar to the one that's on your paper, but I want to show you this one because I can create stuff with this. You got a triangle facing this way. It's a right triangle because you got a right angle here, and it's facing this way where the hypotenuse is kind of your base right here. If I were to take a measurement, considering this to be my base, if I was to take a measurement from the bottom to the very top of this triangle, that would be me taking a measurement of the altitude of this triangle. Altitude is the height of a triangle, how tall a triangle is, from its base to its top point. In this case, base of my triangle would be here. The top point would be here. This is a height measurement right here. By doing this, though, what they're saying is you split this big triangle into two smaller triangles inside of it. If you can see that. So this whole thing is a big triangle. But when I draw this altitude in, this height measurement, I got a small triangle right here. And then I got one that's a little bit bigger, but a triangle here too. Can you see both of these? Yes? They're also saying that these triangles are right triangles. So right angle here and a right angle here. If that's the case, what they want you to know about this, let me connect for you. That these two smaller triangles that are created are right triangles. But they're also, depending on the way you look at them, inside of the big triangle here, they're all similar to each other. So let me show you. If I flip this, and turn this up, zoom out, all these right triangles are similar to each other. Similar meaning they are proportional to each other. Y'all should know that. We've been working on similarity this whole unit. Don't all three of these look similar? Yes. So they're proportional, meaning that this side is proportional to this side, and this side is proportional to that side. Same with the bottom side. It's proportional, proportional, proportional. Here, here, and here as well. But they won't ever split them for you like this when you're looking at the big triangle. They want you to understand that there are relationships between these sides. But it's going to be hard to match the relationships up because all these triangles are kind of put together into one. Like, for example, depending on which triangle you're looking at, the proportional sides kind of go with each other in different directions. What I'm saying. So if I'm looking at the big right triangle, the biggest one here, this will be my hypotenuse, this side at the bottom, yes? But if I'm looking at this small right triangle here, this will be my hypotenuse. If I'm looking at the middle size triangle, like the medium one, this is my right angle, this is my hypotenuse over here. Y'all follow me? That being said, that's saying all these sides right here, which depending on which triangle you're looking at, are hypotenuses, and they're similar to each other. But it's all based on which triangle you're looking at. So it's kind of hard to really figure out how to write the proportions when they have numbers in here to solve for these triangles. So we give y'all methods. Now there's two, like I said, there's two theorems here: geometric mean using the altitude, and then the leg theorem. It's hard reading these words to figure out, but we got two methods that are created to help y'all write the proportions correctly. For the geometric mean altitude theorem, we use heartbeat. For the leg theorem, we use boomerang, and I'll explain to you when we use which one. This just helps us write our ratios to solve for whatever missing side we need to solve for. So let me help you write a ratio first. Let's talk about heartbeat. We're gonna make a note on the heartbeat too. And the heartbeat, put a little star here. We're gonna make a note. Let me zoom in a little bit more. Use heartbeat when there is a number, and I'm gonna use a hashtag for number, or variable on the altitude. So whenever the altitude of your triangle has a number or a variable on it, if there's anything on your altitude and you're solving for something using that, you want to use heartbeat method. So in this case right here, looking at this one, they got an X on my altitude. So once I see that, I know I'm going to use heartbeat. And you can kind of see why we call it heartbeat. I'm sure some of y'all have seen heart monitors before and how the heartbeat goes on the heart monitor. That's why we call it this. And that's essentially how you're going to move across the triangle with your pen or your pencil. And that's how you're going to write the proportion too on this one. So, and you can go left to right or right to left, but I always go left to right. But either way, you should be able to write the same proportion still. Left to right, I'm going across the bottom here, going across A. So since I go across A first, that's what I'm going to write first, up in this top left of my proportion. A. Then I go up the altitude. I travel up the altitude, I pass by X. Since I go up the altitude and I pass by X, I'm going to write an X. Then I come down that altitude again, I pass by X again. I'm going to write this other X on the top right. So you go left top, left bottom, then right top, then right bottom. And then I come down, and then I go across this side right here with the B on it. Doing heartbeat helps you write this proportion correctly. Of course, it's not always going to be all letters. We're going to put numbers in, but right now we're just practicing with y'all. Like I said, you can go left to right or right to left. Even if you come back right to left, just do the same thing, just follow the same path. If I come back this way, if I start here and go right to left, I'm going to go across B first. Then I'm going to go up to altitude X. And then I'm going to come back down on the altitude X. Then I'm going to go across A. These two proportions are still written the same. They're still going to give you the same thing. Because if you think about it, in the proportions, you're still multiplying A times B and then X times X. Same here. B times A and X times X. Still going to match up the same. You can go right to left or left to right. Just make sure you do the heartbeat. Alright, so that's the heartbeat method to set up a proportion. The next one is boomerang. I don't write no note on that. I probably do need to write a note. Basically, use boomerang any other time. Anytime your altitude is not labeled and you have one of these sides over here, outsides labeled like this, you're going to use boomerang method. And y'all know what a boomerang is. You know, the Australian little thing they throw around. We call it that for a reason, because you kind of go, come out, and then you kick back the same direction you came. But with boomerang, the only thing you need to understand is, like, depending on which way you're going, the way variables and numbers are set up, you do the short leg first, come up one of these sides, then come back down that side, and then you can do the whole distance across the bottom. Even if I was on this other side right here, if you were boomeranging this other way, and let me do this in another color. Don't do this, don't draw this unless you got another color. Like, even if I was coming this way, say I had another variable, I don't know, D over here, and then let me make another one up, I don't know, E, yeah, that's fine. Coming back this way, I would boomerang this way. I would come across this short side this way, then go up, then I would come back down. Getting sloppy with my arrows, sorry. And then I would come across the whole bottom this way with my boomerang, if I had to come the other direction. That is very sloppy, I'm sorry I wrote it like that, but whatever. We're going to do the black one right now, though. The black one, so going across, you go across X first, then you go up A, then you come back down that side A, and then you go across the full bottom C. Like I said, my one in green that I did, I know y'all don't, you may not have that one, but I just want to show you, if I was coming from the other way, doing this other side, I would go across D first with my green one. Then I would go up E, come back down E, and then I would slide back C the long way. If I had the boomerang that way with the other letters that I wrote. Alright, ain't nothing to it but to try it. Lindsay back. First thing you need to be able to do on these is identify which method you're using. And until y'all get good at this, I always want you to label that first, so I know if you're even choosing the right method when you're starting out. Using heartbeat and boomerang to solve for the missing variables. Find the missing length indicated. Leave your answer in simplest radical form. So in this first one, Chris, make a decision for us. Based on the way they have this triangle labeled, which one are we using? Heartbeat or boomerang? I asked Chris, I ain't asked all y'all. Huh? Explain why. I think you're just guessing. Aiden. It's heartbeat. Tell me why. Thank you. On your altitude, you got a number or a variable there. 10 is there. We're using heartbeat. We just talked about this. Pay attention. Alright, now, like I said, this one's kind of upside down, so it's your choice though. But like I said, I go left to right. So I will start here. I will come across, and the first thing you want to do, let's label first, I'm sorry. He said heartbeat. This is heartbeat. We're going to write heartbeat at the top, make sure we know what we're doing. So I'm going to come across, then I'm going to go up the altitude, come back down the altitude, and then I'm going to shoot across. Well, let me do it on the outside. Shoot across this way. I'm just drawing my arrows for myself. It's the best thing to do. Alright. So how would you write this one, Aiden? Go ahead and finish it off for me. No. Using these numbers, bro. We just did the arrows, so just tell me.
I'm not sure.
Okay. Armando, go ahead. No, man. Where y'all getting A from?
5/10.
5/10 equals. Lord have mercy. 10/x. Why y'all putting letters in there that ain't that no more? We're using numbers now. We going. When the variables on the front was just to help y'all understand how to label. Now we're using numbers. We solving now. Alright, so that's our proportion to solve for x. Once you write the proportion correctly, it should be okay for you to solve for x. Go ahead and do what you got to do. Cross. 5 times x, 5x. Over here, 10 times 10, 100. Divide by 5. 5 by 5. X equals. Thank you. So that's telling you the value of x on here is equal to 20. Oh, we got a box down here. Alright, line. X equals 20. Yeah, that's the situation. Number 2 might confuse somebody. Let me go with Vincent on this one. Vincent, number 2, what you gonna use? Huh? No. Yeah. Anytime you get your altitude label like this, we're going heartbeat, and especially on this one, because that's what the altitude is what we need to find. It's got the variable x on it, so we can't ignore it. I know what's throwing y'all off though, but we did this on purpose. Y'all should know we did this on purpose. We still got to move the way we're supposed to move. So we're doing heartbeat because the altitude is labeled, and our movement still has to be the same. So our movement is, if I'm going left to right, I'm going from here, I'm stopping at my altitude, I'm coming up, then I'm coming back down, and then I'm finished going across here. By me drawing that should key something off to some of y'all. What I need to do first? Juan, you don't see it? Jamal, what's up? Exactly. Say it louder though. Subtract 100 from 36. Why? Because I need this little length right here. And that's 64. So this length right here will be 64. Now that I have that, I'm ready to write my proportion. Jamal, go ahead and finish it. You going that way? Okay, that's not the way I drew my arrows, but that's fine. Yeah, thank you. 64 over x. Yes. Cross, cross. Don't get big numbers, don't be scared though. What's x times x? No. X plus x is 2x. What's x times x? Let's try again. X times x. Lord have mercy. What's x times x? Sophia, what you got? Thank you. One person in here. Lord have mercy. 64 times 36. I'm gonna need that number. I don't know it. Okay. 2,000. Yes. Hold on. Let's do one thing at a time. Now you got x squared. We still solving for x. How we get it squared off of x? Square root. Square root. Square root of 2,304. 48. X equals 48. Now that's the reason we showed y'all simplifying radicals too. When y'all get something like this and they don't come out to be a whole number, you're gonna have to simplify that radical for us. Hopefully we won't have one that big that you have to break down. I don't think we will. Oh, I lied. I think we do. I think number 4 is that big. And number let me do one more before you go. Number 4 we'll do tomorrow before we do the practice. Alright, number 3. Thank you. We're using boomerang. On this one we do boomerang. I always do my short leg first. So it is boomerang on this one because the altitude ain't labeled. So on this one I'm going here first, inside, then I go up, come back down, and then I go across the full bottom. Let's see if y'all write this correctly. Let's see what y'all thinking. Dior, go ahead. 2 over x equals over 14. Good. Y'all follow that? You should know where 14 came from. You should be smart enough to know that. Crossing. Here. 2x. I'm talking about 2x. I'm messing up. I'm doing y'all. X squared. You know you can't get no decimal. At the top it says simplified radicals. It says 28. So square root. Cancels. Well, since you added Dior, we might well break it down with me. What's up? So 7 times 4, 2 and 2. Okay. 2 come out. So x equals what you said? 2 what 7? Say it correctly. 2 square root 7. So 2 and 7. Okay. Alright.